Okay, we're looking at mixed exercise 7 from the first year core textbook. So that's on algebraic expressions. We are on question 10. So we've got an exam question. So we can see that the first bit is worth 6 marks. Okay, so we've got to factorize this. Now, you could put it into your calculator and get the solutions, but that's not going to earn you 6 marks. So in your exam, they're going to find a way of wording it so that it says that calculator solutions are not acceptable. So assume we're doing it from scratch. So first thing I need to do is decide, well, what can I take out as a common factor? And I'm going to do that using factor theorem. So factor theorem is where you substitute a value in and you're trying to get it equal to 0. So looking at the 5, the only things that are worth substituting in are the factors of 5. So that cuts things down quite a lot. So 1, 2, 2, what we're talking about. 1 or 5, basically, or -1 or -5. So let's try 1. That's probably just the easiest to start with. And actually, you do need to write your working down, but I can see that if I substitute 1 into this, it is going to equal 0. So I do need to show that I've done that. And yeah, so it may not be that you find the correct factor first go. That's fine. You should be able to find a value that when you substitute in, you get 0. So if I substitute 1 in and get 0 out, then x minus 1 is a factor. So I could carry on and just find all the other factors that way. The only thing that puts me off doing that is the 2x cubed, because actually I did misspeak earlier. Because of the 2x cubed, it could be that one of the factors is, for example, 2x plus 5. And to find that, I would have to substitute in minus 2.5 or minus 5 over 2. So I think now I've got a factor. I'm just going to do the division. So, so the cubic is 2x cubed plus 9x squared minus 6x minus 5. So I'm going to do it through inspection, and then I'll run through it quickly if you prefer to write out the division. So, oh, we need to make that bigger, never mind. Okay, so, so I know that a cubic is going to be a linear set of brackets multiplied by a quadratic. And I know that when I multiply, so if I think of this in reverse, if I was multiplying these brackets out, the only cubed term will come from x multiplied by the x squared term. So that tells me the first term in that brackets must be 2x squared, because that's going to then give me 2x cubed. Okay, I can then use the same logic looking at the constant, because when I expand these brackets out, the only constant term will be -1 multiplied by this missing value. So if that is supposed to equal -5, the constant must be +5. Okay, so that when I do -1 times 5, I get the constant of -5. So though the first and the last term, or the x squared term and the constant term, are always quite straightforward. A little trickier to get that missing middle term, but I could do that 2 ways. I can look at the x squared on the left-hand side. So I can look at the 9x squared, or I can look at the -6x. So I'm going to use the 9x squared, and then I'm going to use the -6x as a check. So if I were expanding these brackets out, where would my x squared terms come from? Well, the -1 times the 2x squared, which will give me -2x squared, and the x times that term there. And altogether, I need that to equal 9x squared. So if it's supposed to equal positive 9x squared, and I've got -2x squared, I need that to give me 11x squared. So that would have to be plus 11x. Okay, and then I can check using the x term. So if I think about where the x term would come from, well, that's going to come from -1 times 11x, and from x, that should be -11x, and from x times 5, and together they would give me the -6x. That's just a way of checking that I have got that middle term correct. Okay, so that I think is the quickest way to do it. You're not totally sure about that, you're not feeling confident about doing it that way, you can just do either the algebraic long division or reverse grid method. I'll just run through it with reverse grid method, that's a bit quicker. So I am doing this quadratic divided by that cubic divided by x minus 1. So that, as we've already said, is going to give me a quadratic. Let's do a little bit of colour coding. So when I'm filling my grid in, that's going to be the only cubed term. They will both be x squared terms. They will both be x terms, and that will be the constant. Okay, so, and it is exactly the same reasoning that we used when we did it by inspection. So that needs to be 2x cubed, which means that must be 2x squared. If that's 2x squared times minus 1 is minus 2x squared. I need 9x squared, so that's going to have to be minus 2x squared plus 11x squared. If that's supposed to be 11x squared, that will have to be 11x, so that times that gives me 11x squared. If that is 11x, 11x times minus 1 gives me minus 11x. My x term is supposed to be minus 6x, so I need to have a plus 5x there. For that to be 5x, that's going to be x times 5, and if that's 5 times minus 1 gives me minus 5, and that last term is really just a way of checking it works, because we know that x minus 1 is a factor, so we know there shouldn't be a remainder. Okay, so whichever method I've used, it's, oh, I need to use black there, it's given me the same quadratic. Okay, and obviously if you haven't put minus, you're implying that they're both positives. So whichever method, obviously you wouldn't do it both ways. So did they tell us what to call it? Yeah, so we're calling it g of x. So what I've found so far is that g of x is x minus 1 times 2x squared plus 11x plus 5. And all it said was factorise fully, or factorise in fact, but assume it means factorise fully. So that could be the final answer. Depends on whether the quadratic factorises or not. So, of course, you could always just stick it into your calculator and see if it gives you rational roots, if you just wanted to check whether it factorises. I think it does, they normally do. So if it does factorise, 2 is prime, so it's got to be 2x and x. 5 is prime, so it's just deciding which way around the 1 and the 5 go. So if I do, if I do 2x times 5, that gives me 10x, x times 1 is x, so that would give me the 11x. And I think that was it, wasn't it, for part A? Yep, so we have factorised it fully. Okay, and then part B is only worth 2 marks, because actually we've already got the answers to part B. If you have factorised it, you've got your 3 solutions. So if x minus 1 is a factor, x equals 1 is a solution. If 2x minus 1 is a factor, x is minus half is a solution. And if x plus 5 is a factor, x minus 5 is a solution. Okay, so really that's just sort of checking, the difference between factors and roots and what it actually means by solve it. Okay, so let's just quickly check those. I can't see any problems. No, we're good.